but that's what the XC market wanted, and I just didn't understand it at all. Like, what is happening to me? Is my fork leaking? Maybe even cause problems for the end user where they just really never could get happy on it.
Hey, what's up, guys, and welcome to another episode of the Loam Wolf MTB podcast presented by Feedback Sports. Do head to the description below where there'll be a link to get a discount on any tools that you need. Today for this episode, we've got Tim Lynch, the RockShox design engineer, and we're going to talk all things suspension. Tim, can you give us a little introduction to who you are, your job, and how you got into it?
Sure. My name is Tim Lynch. I'm the chief engineer at RockShox. I've been working there for 20 years this month. Started working on rear shocks years and years ago, and have now just kind of worked my way through the entire product line. So, yeah, lots and lots of years of making decisions about bikes.
And these days, what does your job involve mainly?
These days, I get to lead a group of people who are doing the hands-on work, and I get to help kind of guide us through product development, which is a very fun and exciting, but also treacherous path towards bringing something to market. But we have a great crew back at the office. Couldn't ask for better people. Invested in bikes, love the work, love the sport. So we're having a lot of fun right now. Yeah.
20 years is a long time to be in the game. Over that time, how much has changed?
Well, yeah, there's maturity in the sport that didn't used to be there. But also in the technology and in our business. When I first began this job, I wore a lot of hats. I would be the test engineer, for example. Now we have a test engineer. I would be the quality engineer. Now we have a dedicated quality engineer. I would be the design engineer, which is the role that we have several of now. So we've outfitted our teams. They've filled out that leads to maturity of product as well, right? Like better, more skilled, more focused people doing the thing to create a good outcome. The entire sport wins. We start to get, better reliability of product, better understanding of the performance metrics, better execution, and it builds generation after generation on projects. I think, we might be on Super Deluxe 5 at this point. We started with 1 and we learned everything, So it's happening like that all through the sport. It's not just our company. I think all the frames are better. It's hard to find a frame that's really messed up anymore. Where 10 years ago, some of them could be very unique, and that caused challenges for people like us who are trying to fit that frame with a shock and make it work good for the end user, and it maybe even cause problems for the end user where they just really never could get happy on it. It's rare for that to happen these days. I think a lot of the bikes are excellent. Yeah.
How involved are you with helping bike companies keep their designs within the realms of what you guys can work with?
It's an interesting conversation. The different brands are our customers, and we are not going to try to take information and transfer it from one brand to the other. That's bad business. So a while back, I did go deep into the study of frame design along with a couple other people in our company, and we talked it all through, and we were in a unique position because we do work with a lot of different brands. So we could, kind of understand for ourselves what made a good bike and what made a challenging bike. And we distilled that down into some really basic guidelines that we kind of have shared with our customers. Like, hey, if you guys keep it, percent rising rate on your leverage curve. If you're up by 45%, it's very difficult for us to fit a shock to that and have our end user be able to get full travel. That type of general guideline we would provide to our customers. It's not that helpful in the conversation for us to get much deeper than those general guidelines because it, like I said, we want to leave each brand with their own competitive advantage against each other. I don't want to get in the middle of that. But yeah.
Are there any or many brands who are asking for very specific things out of RockShox to match their bikes?
Sure. Yeah. As much as a brand wants to engage us, I think we're equipped and interested in those conversations. I know the folks above me, they want to be viewed as the best partner for a brand. So if a brand has a specific idea on how to make something amazing in the marketplace, we are right there to support them, and we'll bend over backwards for that. We will execute a custom project and do it well. Try to help that brand succeed. But then our baseline offering is also something that we're fully invested in and making sure that's top notch. So,
could you foresee a bike design, a suspension design, where your product, designed obviously to work within a certain range, would it get to the point that you would just straight up say, you can't use this, or you shouldn't use this on your bike because of any design calls that you've made?
No, it usually comes up in some shortcoming and everyone's aware of it. And then, it gets out into the marketplace and eventually the customers, the market never lies. It all comes out in the wash kind of thing. You're like, yeah, there it is. found the corner that we designed ourselves into as a group, And so we try to head those off whenever it's really obvious. But, each company is motivated by different things. They're trying to make their mark in the world. Yeah.
Are there any designs that make it more difficult for you to design products? Things like yoke extensions.
Yes.
Are they limiting, optimization?
Yoke extensions on rear shocks drive structural needs that otherwise wouldn't be there. It's not great to use the shock as a strut, a structural member or anything, but we do a fair bit of testing and we attempt to make the thing robust because we know that some brands are using that and they're driven by lots of decisions internally, whatever it is they need to do to execute that. So we have specific testing and design requirements built around making sure that our product's robust even if it has a yoke extended to it. But I think us and our competitors agreed, there used to be a 12-inch long yoke attached to some designs, and we're like, please, that's too much. So there are limits. I don't remember the specifics right now, but there's a limit that I think kind of the industry agreed is if you're going to put a yoke on there, don't make it too big.
And would it be safe to say that those same structural concerns also apply to alleviating any problems that might come from frame misalignment? Does it almost work in the favor of that?
Yeah. Again, we've seen a lot of frames over the years with a lot of different manufacturing quality. We're trying to not have our product be the weak link. So we have some really aggressive tests with side load. And, internally we feel like if our shocks pass that test, we can high five and be proud of it. And it's going to go out in the marketplace, and hopefully we can keep our warranty down around that, 1.5%. That's usually our goal. Of course, things get weird and we might fail at that, but that's definitely our strategy, and we've built a lot of internal testing to get us there. So
yeah, I guess people can never be mad about a product failing because of something else that's causing the issue, right? But it's bound to happen.
It's bound to happen in some cases.
Going back 20 years to when you started, what were the first products you were working on?
My very first project was Vivid Coil as its first embodiment. Before that, RockShox, I don't even know the history. Something about a super deluxe with, high and low speed compression, high and low speed rebound. I think it was called the Super Deluxe or Pro Deluxe. And then there was this gap in time where we didn't make a coil shock at all. We didn't have a downhill product because RockShox about to go bankrupt or something like that. So I kind of SRAM had just purchased RockShox and was getting it to become a stable place again. I think they had a very tumultuous time there. And so I was maybe one of the early hires after SRAM had taken over, and I was hired in as a RockShox employee. And I was all about downhill and, thinking about free riding and all the stuff that was cool back then. So I couldn't have been more excited to have that as my first project. And our collective tribal knowledge at that point was pretty low. I'm like, I think I was like a 24-year-old, something like that. And I'm like, who do I ask? Anyone in this company know what we're doing? And I had a mentor. He was awesome. He shared with me a lot of stuff, and then got pulled into a different project because we were all spread pretty thin back then. And so it felt a little bit like, I was getting my feet under myself while we were building the plane while we were flying it, kind of thing.
Right.
So yeah, we did a lap through Vivid Coil. It was a mediocre product. We, I think, did another lap through Vivid Coil to fix it up and make it better. Then I jumped into Vivid Air, and I spent 2 years designing Vivid Air. At that time, it was not common for us to spend that long in a development cycle. What happened with that first year is I really dug in and understood air springs. And like I said, there was no tribal knowledge in our company at that point. So I was given the challenge by our product manager, who was Jeremiah Bubar at that time. He was like, make this coil shock or this air shock ride like a coil shock. And the other air shocks in the marketplace at that time had massive knees at the beginning of stroke, really tiny negative springs. They felt terrible, like I would never have ridden one ever. But that's what the XC market wanted, and I just didn't understand it at all. So I just spent time figuring air springs out. And I would say that year of study is what has fueled me my entire career, honestly, almost all the way up to this MY27 project. I'm still able to, shoot towards the same things that I was learning in that project, even though I was very immature at that point, and, we were coming up short all the time there. It was very foundational for learning. And that's kind of how I took that piece of learning, dumped it into Debonair, which was at the time revolutionary for cross-country shocks. I think it showed up on a Monarch Plus maybe. Mm-hmm. And I think Fox had something similar called the Evol. It came out shortly after that. And but it's that concept of really digging into understanding what happens if we push the negative spring bigger. What do you pay? Everything's a trade-off. What's it cost us to make that negative spring big? And then working through all those details. So yeah, and then that has fueled, like I said, even this MY27, this new Zeb and Lyric and Boxer that we're rolling out right now. It's the same conversation, just 20 years later.
What do you think is the biggest improvements that we've seen from those 20 years ago shocks up until now? Where have the biggest gains been made?
Back then, we were way worse at making our seal designs. So it was kind of inconceivable to make the Vivid Air ride like a coil. I failed at my mission because we had so much friction in our air springs. And there's a lot that's gone into understanding that. Those dynamic seals, we've unlocked a few secrets in there. And I think you can get this new Vivid Air, and it's not a massive delta between the Vivid Coil. I don't know if we've made them the same because there are limitations due to physics why you can't. But we've gotten really close. So it took our team a long time to get there. It started out as me. Now we've got a group of people working towards it, and they're excellent at their jobs. And we're getting closer, I would say.
So you've touched on the new product there. big overhaul in the more gravity side of things, new products from top to bottom. Maybe we can talk about, just go through them systematically. I guess the shared features across the product ranges, and then maybe a few little specific details for each of the products.
Yeah, I'll try. So if we want to consider forks and shocks, we're kind of thinking of like Boxer paired with a Vivid Coil. Zeb maybe pairs best with the Vivid Air, and Lyric maybe pairs best with the Super Deluxe. You're welcome to mix and match those however you like. But, just to keep our thoughts organized here. If we're talking about air spring design, every one of these designs, I'm going to do the regular bigger negative spring conversation. The trade-off there usually is if you make a negative spring bigger, you end up making it ultimately more rampy, and you run out of room to really, keep the conversation moving in the correct direction.
And that's because you're compromising on positive spring volume.
Yeah. You make the negative spring bigger. Now it's more effective longer into the travel. So then you have to put more positive air in. And so, you're doing this push me, pull you, and the end result is it's more rampy, more progressive, which needs to be addressed. So in our forks, the way that we paid for it on this newest development is we identified that we don't really have a use for the casting spring. It's a third spring in the equation in a fork that we just don't need. So you'll see that we have kind of this air annex at the bottom of our lower leg on the new forks on the air spring side where we were running into that limitation. And that's essentially a way to make the casting volume large enough to where it's out of the conversation. Then we can do exactly what we need to with the positive spring, balanced by a really healthy negative spring. End result is like allowing us design freedom to hit the targets we were shooting for. Trying to parallel that into the shock world. I don't think there is no equivalent of the casting conversation in the shock world. But what we did is, have a look at our spring designs, make sure that we've got them linear through that first 30% of travel. Make sure we're able to address, the flattest curves we need and the most progressive curves we need with our token systems. And then specifically to Super Deluxe and Vivid, our two long travel air shocks, we found a win by making our communication between the positive spring and the positive spring extra volume. We made those communication ports bigger in order to make sure we weren't causing unwanted restrictions in airflow. That same thing is paralleled in the forks as well. We really went to great lengths to make sure that we knew exactly where and when the air was traveling in between its different chambers. So. And
to explain that further, that's the effects of hysteresis.
Yeah.
That you're trying to alleviate. So air transferring, I guess, in the shock between the main positive volume, where it's probably going to be felt first, into the external additional positive volume.
Yeah, where the sleeve is. Yeah. We don't want any restriction there. We did a big study. There was some thinking in our kind of collective of people who love bikes and dream about this stuff. We actually had some thinking that maybe we liked some of that hysteresis. And so we studied it and we built some A/B samples and ultimately decided that no, we don't want to go that direction. We want there to be good communication between those two chambers. And we did the same thing on the forks. There's a parallel conversation there we can get more into, but ultimately we wanted all the chambers that represent a volume, we want those to talk to each other lickety-split. And
without that happening, if the ports were much smaller, what would people feel?
So you kind of have if you hit at one speed, let's call it 50 inches a second, kind of like a fast but not incredibly fast hit, you're going to have one spring curve. And if you hit 150 inches a second, which on a shock would be considered very fast, you might have a more rampy, as the air tries to all get through that tiny hole, it can't do it. And then on the return stroke, you have a bit of rebound damping as the air tries to fill the chamber again. And, we thought we kind of liked that rebound damping. And as we dug into it, we came up with the philosophy, no, let's make the air spring do air spring jobs. Let's make the damper do damping jobs. We can control them much more intentionally. So, yeah, it's that type of conversation. Same thing's happening on the fork as well. But
okay, so we've dialed in the air spring.
Yeah.
What's next in the development?
Friction reduction. We touched on that a second ago with the shocks. We got way better at seal packs. This latest Vivid, we found some stuff that was left on the table in our last design, tightened that up, and it's a better product at this moment. In the fork world, we did a lot of work towards friction, and that's a very complex conversation, having to do with chassis alignment, having to do with bushing design, having to do with all the statistics that control trying to produce, over 100,000 forks in a year, all with good performance. Another thing that we've worked into that conversation is our lubrication system. If you're making something that needs to slide, you better worry about how that surface works from a grease and oil standpoint. And we worked with Maxima. They have an excellent grease, SG920, which has been really great for us. And then we've also gone to a heavier weight chassis oil in our forks. It was a 7.5 weight. We're moving to 15. In the marketplace, it's known as the light and the medium. So we're now at the medium. Our SID product uses the heavy. So Lyric, Zeb, and Boxer are all now using that medium lube oil. There's more of it in these new designs because we aren't limited by our casting volume anymore. We could add the appropriate amount of lube oil to the system to make sure that we're never running in a compromised state. And then having that SG920 grease, I can't overstate the importance of the lube system. So,
and where is that grease gonna be for those who don't know, haven't built a fork?
Yeah, so you have these scrapers that are right on the stanchion that keep the dirt out and keep the oil in. It's right there. There's also some on the seal head of the air spring and the main piston on the air spring, and then the seal head of the damper. So any dynamic seal, anything that's moving, we're using that SG920.
But crucially, stuff that's inside the fork, not outside, right?
Correct. Yeah.
Grease is not gonna play so nice with dirt. Yeah.
Yeah. No, this is all talking about our internal lubrication system. If you're driving a race car, you go around a corner too fast and the oil gets slung to the outside of the motor, you blow the motor up. It's just that quick, right? You need oil to keep these mechanical things running, right? We are no different. These little machines are getting wrung out, so we got to keep the lubrication in the right spot. So we have two other things I haven't touched on. I talked about chassis alignment. I talked about bushing sizing. We have our dirt scrapers, those dirt excluders. We worked with our vendor, SKF. We identified a problem that as you go down and you compress the fork into travel, the pressure in that casting volume goes up, and that takes those seals, which have kind of a shape like this, and when they get pressurized, they go and grab the stanchion.
Okay.
And we phoned up SKF, said, hey, this is a problem. What can you guys do about it? They're the seal experts. They worked on it for a few months, came back to us with the solution, and they knocked it out of the park. So step forward with our seals. That's always nice. And
Just touching on those seals, so what you're saying is that it goes from a V shape, and then they're like squeezed almost into the stanchion, and then you've got extra surface contact and more friction as a result.
Yes, that's exactly what happens. Yeah. So yeah, getting rid of that problem gets rid of this inconsistent damping. Like you go, let's say you're deep in travel and there's high pressure, it'll grab your stanchion. You know, our entire philosophy here was let's make this thing consistent so that the end rider can just trust what's going to happen when you hit a feature. It's not going to do anything different than it did the time before. It doesn't depend if you're high in the travel, low in the travel. It's, you know, each system is managing the thing it's supposed to manage, and then each system is behaving consistently, you know, independent of the input a little bit. So that was our goal. We found a few wins in that. So the last thing related to reducing friction and increasing like lubrication distribution and all that, we have a new technology. I would say patent pending, kind of cheesy. We have this array of divots all around our upper tubes, and it's not fancy. It's inkwell technology. The stanchion goes down into the oil bath. Those small divots grab the oil due to surface tension, haul it right back up into that bushing. And then, you know, in some cases it goes past the bushing, and as it goes back, it's going to get scraped off. And so there's this nice pool of oil above the bushing, just keeping those bushings lubed. When we first conceived of the idea, we're like, we don't know if that works. It works in our minds. Let's see if it works. So I guess we came up with this test. I could try to describe it real quick if that's interesting.
Yeah.
We had a lower leg and a fork, so apart from each other. We put the oil only in the bottom of that lower leg, and we built the rest of the fork dry. And so that means our foam rings at the top of the bushing system and right below that dirt scraper, that was a dry foam ring. If you're familiar with rebuilding a fork, we always soak those in oil. So we put those in dry, and the only oil in the whole fork was in the bottom of the lower leg. Then we took the fork and put it on our sim machine, which, you know, simulates, I don't know what, a couple hours or something of actual trail riding. So it's doing all different stroke lengths and shaft speeds. And
you're getting dyno plots out of that?
There's no data in that test. We're literally just putting it on the shaker rig is how you could think of it. But it is data that we grabbed from a pro athlete on a specific trail. So it's...
Do you know what athlete and trail?
Man, my brand guy's gonna bust me for not knowing this. There's this sick, on our landing page, there's this sick video of Troy, and he's shredding, and next to him is the sim file. So it's showing his fork going up and down, and the sim machine is doing its thing. And so I'm going to go out on a limb and say it was Troy, and I can't be 100% confident in that. But yeah, that's the spirit of it, right?
Cool. Yeah.
It's a real athlete, and we can basically duplicate it in the lab. And it's a very cool machine to watch. I mean, it's impressive. So put this fork into the machine, watch it bounce around, take it off the machine after a certain period of time. And we had also built a control fork, right, without these divots on the outside of the upper tube. And so the control fork we take off and look at those foam rings, they were still dry, meaning oil was not being transferred up to them. Mm-hmm. And we look at the one with the divots, and the foam ring was well lubricated, meaning our theory worked. We're going down into the well, grabbing some oil, pulling it up, getting oil all over the inside of that fork, which is the exact place you want it. So,
cool. It's a nice bit of validation, I guess.
Yeah, of course. The test. I don't want to oversimplify the test lab's work. They went far deeper into the study, but I think it's a fun story.
Yeah. So. Okay. So, and you're calling that
Butterwagon technology?
Where did that come from?
Yeah, in our office, we have several teams, like the XC team, the rear shock team, and then for some reason the long travel team wanted to be called the Butterwagon team because, butter's smooth, and I'm not sure what. It's the same. It's the same reason we have butter cups, as a play on that.
Mm-hmm.
So here we are again doing the butter thing, and it's a good team building thing, I guess. It's kind of funny.
Okay, so we've got all that friction reduction. What's the damper done to accommodate that?
Right. Yeah, people will jump towards the damper because that's the thing that they imagine in their mind they're experiencing. A lot of times it's the lube system. So you've pulling us into the exact right segue. We took some of the friction out of that damping system, so it's mandatory that we build it back into the damper. So it's better to do your damping with shims and hydraulic oil because we can control it and be specific about how it's applied. If it's done with just friction or drag, it's damping, but it's not the best.
Would it be safe to say that it's more random, unpredictable?
Yeah, it's not even that. It's that we can't manipulate the curve shape. Okay. And we like to do that. We will say, hey, we want this amount of damping at this shaft speed, and we'd like to have a different amount when we're in this shaft speed range, and and that's why you hear us call it low speed, mid speed, and high speed. With friction, you get what you get. What it presents as is a lot of low speed, and then not a lot of high speed, and that's usually fine. We don't want to have high speed develop that way, but it's the low speed that wears your hands out sometimes if it's not good.
That's the parking lot test classic as well, right?
Yeah. Like if you're in the parking lot and pushing, you're probably going 15 inches a second. If you're in a berm and it's really loading in there and you can kind of feel the seesaw kind of stability of your bike, that's 2 to 5 inches a second. And then if you're falling off a drop or something, you might be up in the 250 to 300 inches a second. Hitting water bars or breaking bumps, that's probably like the 150, 175, depending on what's going on.
And that would be talking fork rather than shock.
Fork, yeah. And then everything kind of gets divided by 2.5 or 3 in the shock. So when we put the damping back into the damper in the way that we wanted, we were very specific with it. We did a lot of back-to-back testing, a lot of invested people making suggestions, checking our work. I think one of the cool things we've done with this latest development cycle is we have a really neat internal feedback system for us to check our assumptions. It's really easy for ego to be the main driving force in these conversations, and then you don't get the right answer sometimes. So we've been able to spread this out amongst a group of really invested professionals that are working in different parts of the world. And then also we involve our engineering staff heavily. We really encourage the engineers to experience it themselves. And we'll set up blind tests where the guy who invented the concept or is promoting that concept doesn't even know which fork it's in. And we'll have everything else equal. And we'll just say, hey, which one do you like? Mm-hmm. It's blind. And we come out with an answer, and we'll test 4 or 5 guys with that or gals with that. And we'll take all their feedback, and then we'll unblind everyone, and we'll all chat it out in a, hopefully low conflict conversation, or conflict is acceptable kind of conversation, where it's it's a trust tree. Let's figure this out. We want to know the right answer, So I'm really proud of our team for developing those skills, and it's fun, right? If a team's running right, it's a good thing. So.
Okay. So I think it's quite funny that the forks, when you gave us a presentation the other day, basically introduced that the only thing that stayed the same was the axle. Yeah. Why didn't you change the axle?
We actually talked about it, and we're pretty excited about what it is. For one thing, we like it to be easy to put your wheel on your fork. We don't want it to be intimidating or complex or frustrating. So it's nice to have that axle. And then as far as alignment, which is a big reason why you would have a more complex design down there, we have control of that conversation working with our vendor. Actually, that particular step is done in-house in our factory in Taiwan. And we're working closely with that team to make sure that we are not getting thrown any surprises. You'll notice, I think probably it's very common for you to have a little trouble putting your wheel in because the castings come in like this. And you pop that hub in there, torque the axle in, and you are in good alignment at that point. It's probably disconcerting to someone who's not hip to the conversation. Don't sweat it. Once you torque that thing up, that's where it was designed to all come together. And then we study that torque state and use some heavy-duty statistics to prove to ourselves that we can do that.
I guess front hubs are in a pretty good place for tolerance in these days.
It's been our experience that it's not as big of a contributing factor as we fear it is, I guess. A better hub is probably closer towards the exact nominal, but even some of our value hubs are still pretty good. It's usually not the problem. Of course, there's outliers, but yeah, it is part of the game.
So we've talked shared features through especially the forks, but forks and shocks. Can you kind of outline the current new product range?
Yeah. So we've got, in the fork side, we have Boxer. And then we're going to have brand new Zeb for MY27, brand new Lyric. And then on the shock side, we have Vivid Coil, we've got Vivid Air, and we've got Super Deluxe.
And in the forks, there's a little bit more overlap now, I guess, between the Zeb and the Lyric.
Yeah.
Zeb goes 180 to 150,
yeah,
and Lyric goes up to 170 now,
yeah,
down to 140.
Correct.
How are you kind of suggesting that people make the call between each fork in the travel zones that overlap?
Preference. I think Lyric is pointed towards a ride all day type thing. If that's how you like to ride your bike, it rides at a pretty high level. I don't think you need to haul the extra weight around of a Zeb. But the flip side of that is if you're riding an e-bike, let's say, or you ride very aggressively, or you're using this kind of as a park bike, grab the Zeb. I mean, it's got a 38 millimeter chassis. It's a stiffer vehicle. Some people are really loving that 170 Lyric if they're maybe a lighter weight rider on a regular mountain bike, not an e-bike, and that might be the right fork for them. It's really up to you and how you visualize yourself. They do have distinct personalities, and a lot of that comes down to the chassis stiffness, I guess.
Cool.
Yeah.
What's your favorite product out of the new range?
On my e-bike, I'm loving the Zeb.
Yeah.
It's the right thing, man. Full power e-bike with a Zeb is pretty hard to beat. And the Vivid goes right in there. On a pedal bike, I definitely am riding the Lyric. It's the right thing. I got the 160 Lyric on there, and it's freaking sweet with the Super Deluxe. The Super Deluxe, there's been probably that product also is almost ground up. So yeah, it's a beautiful creation.
Can you tell the audience about the new volume spacer design in that? I think that's one of the things that really stood out to me is so simple, but it's like, yeah, it seems like it's going to be super effective. It's really cool.
Sure. If you're a customer who has ever tried to adjust your token count, you might have been frustrated by not having the token. Like, great, extra parts needed. I don't know what to do next. This design that our engineer came up with, Dennis, he just had a clever idea, but essentially you pull the sleeve, the extra volume sleeve off, and it exposes these ribs and a red O-ring. And so if you put that rib, down, then all of that volume counts as positive spring volume. And if you put that rib up, like near the eyelet, then you've cut off access to a bunch of that volume. So you can just move the location of that red O-ring into whichever groove you think is appropriate, pump it back up with air, and experience what removing a token feels like, or adding a token, whichever you were trying to achieve. So yeah, super clever, looks cool. He also was able to key in that air can so you can flip it and get your artwork looking perfect. The artwork is baked on decals, super premium looking. Yeah, he did an excellent job with that shock. He has a novel idea. This is for the real suspension nerds, but it's another like kind of patent pending concept where he can get the refill oil when that shock is extending. We always want that refill path to be easy for the oil, to keep us away from any cavitation risk. And he has a very special circuit that he designed in there, and it just slips the oil right back to where it's supposed to be, and that allows us to run a lower IFP pressure in that shock than any mono shock has ever had, which is advantageous to the end user because it, again, lets the spring do the spring job, not the IFP do the spring job. So we're just trying to keep everyone playing in their corner, doing the function that they were designed to do.
And that all feeds back into the trying to globally reduce friction and just focus on making the control come through the dampen.
Exactly. Have the spring be super predictable, starting with easy breakaway and going to a nice linear curve with a slight progression at the end. That's what the spring should do. We don't want anything to keep that from happening, like a weird IFP design. So he's done that. And then, our damping can just marry into that. If that makes sense.
So can we maybe talk, I think it'd be really interesting to hear from you what the common suspension misconceptions people have, or things that you most commonly see people doing wrong when they're setting up their bikes.
Oh, yeah. Setting swapping your fork or shock can be a lot more difficult than meets the eye. It's actually a really confusing process to hook a shock pump onto your shock or fork. When you do that, air fills the chamber of or kind of that hose all the way up to that sensor location. So you'll have basically a certain amount of air filling a bigger volume, so the pressure goes down. So you could have definitely known that your fork was set at 150 psi, and you plug this thing on there, and it's like 142. You're like, what is happening to me? Is my fork leaking? It's not leaking. There's a certain amount of air that just filled that chamber. So that's one of the things that trips people up.
And that would be equal, also beyond that, equalizing the positive and negative air springs within the system.
I was going to get to that, so
okay.
Maybe I got them out of order, honestly. So let's say that your new suspension has never been filled with air, or you just took your Super Deluxe sleeve off and moved your new red O-ring up a click, and you want to fill it back to 200 psi. That's our mission in this conversation. So do the work, put that on, put it back in the bike, bolt it up, and you have no air, positive or negative. What should we do? So sit there and pump. So we're trying to get to 200. If I pump it up to 200, I've only filled the positive side of the spring. And so that's why when you sit on the bike, it feels like a rock. You're like, this thing is broken. It's another common place to just swirl for a minute. It's not broken. You just haven't put any air into the negative side of that. There's a negative chamber in your fork or shock, and you need to get the air from the positive side to the negative side. So when you sit on it, you're going to push it down, and you'll hear a little point in the travel on the shock. It's probably like 25% of travel or something. And you'll hear the air go, psst, and it fills that negative chamber. And the longer you can hover on that dimple, the more guarantee you'll have that all the air has crossed that needs to cross into that negative chamber. from there, if you left that pump engaged, you had it pumped, to 200 psi, and you got it to swap. Probably now it reads 137, and you're like, I'm not sure what happened. So now you pump it up again to 200, and you get it to swap, and now it's dropped to like 160, and you do it a third time, and you'll just keep working that back and forth until it's 200 both in the positive and the negative chamber. At that point, if you detach the pump and put the pump back on, it'll read 193, and you're like, what happened? So that's the air filling that hose length and dropping your pressure a little bit. So there's all those complexities. Setting sag in a shock or filling a suspension piece with air is actually more difficult and nuanced than anyone wants to admit. So.
And when people are swapping, equalizing the products, do you recommend that they keep the pump attached? 'Cause I think I've had it in the past with a analog shock pump where I'm already getting up near the maximum of some shock pumps, and you like knock it out of calibration. Yeah, that's the word. So yeah, would you say
probably shouldn't? Yeah, you should unthread it and let that Schrader core of the suspension system of that positive chamber, let the Schrader come out and seal that positive chamber all by itself.
Yeah. We've had a conversation with the other media this week, and it'd be something I'd be really interested to know. Does the valve cap on the fork or shock serve a legitimate sealing purpose to the product? It does?
Yeah.
Interesting. I was wrong.
So here's the story. Schrader valves, they're not rated for 1200 psi, which you might see inside of a shock with a big guy on it or something.
Mm-hmm. At compression.
Yeah, at compression. So yeah, that fellow will probably put 300 psi or 350 in his shock. The Schrader core can hang on for that. So when you're detaching your pump, the Schrader's fine. Mm. And then you screw the cap on and then go ride it, and those internal pressures might, be through the roof to where that Schrader core would have lost it. Okay. So there's a seal inside each one of those air caps. You're going to want that, especially if you're a bigger rider. And
interesting.
Yeah. The truth is I've never seen one of those Schrader cores give up. Mm-hmm. It's just that they're not rated for a high pressure.
So the cap it's not necessarily always serving sealing purposes, but it could be a potential fail-safe to...
Correct. Okay. It just stops confusion. Okay. Right? Like if you've got a problem, but you have the cap, then the problem's not going to affect you.
Okay. So. How have e-mountain bikes influenced suspension design?
Great question.
And have they made it better or worse?
It's a heavier vehicle, and we're trying to suspend that vehicle. So it needs a bit more spring rate and a bit more damping. But honestly, it's not much beyond that.
Are you still making e-bike specific products, and does any of that happen to the chassis?
Our chassis are tested to be bomb-proof in either regard, whether it has the e-bike label on it or not. Mm. Both of them are going to not fail. We go above and beyond in our chassis design, I guess. So yeah, it just comes down to, in all honesty, you need a bit more spring, you need a bit more damping. There's not really much beyond that we have discovered so far. In this development cycle, recognizing that Zeb is going to sell into the e-bike market. It's a great e-bike fork. But then it also I've spent all week riding a Zeb on a naturally aspirated normal bike. So in this entire development cycle, we had dual paths of testing for performance. Whenever we were making a performance decision, we'd check it out on a regular bike and check it out on a e-bike. There were one or two times where that was critical, but a lot of times we had shared experiences on both vehicles. So yeah, it's not as not as big of an impact as I imagined it was going to be when I first realized how big, e-bikes were going to become in our sport.
I guess a lot of, we heard a lot of athletes training on e-bikes really enjoyed, especially when they were first coming into real prevalence, really enjoyed the handling characteristics, the extra mass and centralized low weight provides. Is there a lot of talk around mass and, tuned mass dampers and added mass to bikes, and how does that affect the suspension design?
Each of our race teams have their own thoughts on it, and they're working with a racer who has their own thoughts on it. So it's almost like we're around, we're involved in the conversation, we're there to support. It's not necessarily a product that we're creating at this point, so I don't actually care. It's like, you're welcome to toss it on there and form an opinion. It's not gonna really do anything weird to the RockShox product that's in the marketplace or supporting our team. So it's in parallel, and our teams are striving to win. They're striving to up their game, and we're there for it. We're in the conversation, sharing knowledge, and but I don't have a firm stance as far as which way an athlete should go. They're welcome to make their own decisions and explore it. I think it might be track appropriate in some cases. Athletes are, a lot of it's a mental game, so if it helps them feel confident, then we're there for it. Is that a good answer?
Yeah, no, that's perfect. I had it on the lift the other day. Some guy was having a look at the fork and the air annex, and he was like, "Oh, that's cool. RockShox are making a tuned mass damper."
Yeah.
And I was like, "I can't tell you what it is, but no, that's not right."
Sadly, it is much more boring than that. It's not the right product for the general public. The general public needs their spring to work correctly, which we've done. The general, the advanced user or the interested engineer, might want to play with a tuned mass damper and target a certain frequency of bumps and see what happens if they delete them or suppress them. There are wins out there to be had. And then there's conversations of, are we isolating the unsprung mass, or are we isolating the sprung mass, and where are we putting these tuned mass dampers? It's a wide world out there. We're all figuring it out together.
Some deep rabbit holes to get into there, I think. Money no object. How would you build, say, the ultimate suspension fork? What would you do differently to what's commercially available?
Oh man, you're talking to me after just having the freedom to do almost whatever we could dream of for 3 years. It's been a pretty neat time. So I think we built it. It's real close. There's some expensive operations we might have carried out that could help, but there's not that much that we weren't able to really dig into. I don't think I shared this yet, but the team was given a year of, we call it kind of discovery work or pre-development, and so it was a year to research and get deep and nerdy before our normal product development cycle began. And RockShox is part of SRAM, and SRAM is a giant machine. We have a massive factory in Taiwan. There are so many talented people in that factory that can execute things. And oftentimes, once a project begins, it's time to think about getting that part of it running right. And we've underserved some of that pre-development work. But in this project, we were given this year to just study and get excited about the things we were studying, kill some of the weird ideas we had, back up if it was a poor assumption, and go in the right direction. So, it yielded pretty neat stuff. I think if you want to consider like a Lyric and a Super Deluxe for MY27, there are probably 8 significant patents that came out of that year, where the team was just firing, making up cool new technology, and getting patented stuff, working through with our IP department. But a lot of times patents can be annoying. These ones that I feel are actually meaningful. So it's kind of like, it's exciting to the end user is what I'm trying to get at. Mm-hmm. Yeah.
Man, it sounds like a fun year to be working at RockShox. I'd love
cool
to be part of that. Okay, what does the future look like for suspension? Is it just small tweaks to optimize further? Is there significant gains to be made as technologies develop?
Yeah, so RockShox, we've tried to recognize the fatigue in the marketplace. Like, you don't want things new all the time. So, what we've been trying to do the last several development cycles is, we're just completed this project, which was ground up. Like, blank sheet of paper, do what you want. And then we're going to go 2 years from now and we'll have small updates. It'll be like a manageable thing. Like, for all of our customers, it'll make sure the product is fresh and exciting, but it won't make you feel like, I just bought it and now it's out of date. Like, that's not our goal. We want durable products that make our customers feel great. And part of that is the ownership experience. So we're going to go 2 years from now, we'll have some updates. 4 years from now, we'll have a blank sheet of paper again. And the team has already got some stuff cooking. So it's that team is still pretty fired up. They're dieseling right now, cruising. So there's some cool things, but it's 4 years away. So we'll see how it, either turns out great or gets thrown in a trash can. But
do you think there's likely to be more and more implementation of electronics?
Yeah.
So obviously you still have flight attendant as an option for these products. Do you also foresee bike designs pushing more towards reliance on those? We've started to see it happen a couple of times with other brands.
Yeah, there's this kind of myth, like urban legend of someone designing a bike where you just don't think about anti-rise and you just let flight attendant handle it. It's difficult for a bike manufacturer to do that because flight attendant is a premium product. So you could build that into a premium bike. And then how do you make the bike that's, at the lower price point if your entire, development was based around flight attendant and then you can't afford it at the less than premium price point? You get in this like kind of commercial conundrum where it doesn't make sense. So I don't think it's the right solution. Like I said a while ago, like our frames have come a long ways. A lot of those trade-offs people have found the right kind of balance point for a lot of those trade-offs, and bikes pedal pretty good and they descend amazingly these days. So what are you going to gain, So I'm not convinced that that's the right implementation of flight attendant. We are sitting on a really nice technology. We'll see how we choose to move forward with it, and refine it. It really serves the XC world in an excellent way. As far as applying it to the trail and enduro space, it serves a niche. It's not probably mainstream, So I'm not sure where to go from here, but we definitely talk about that daily.
If you had one suspension wisdom to give the audience, what would it be?
Ooh. Keep it simple. So set your spring up and make sure you like your spring. Get that working right. Then move to rebound. Get that working right. Then move to compression. Compression's the hardest one. Actually, we're providing some pretty good setup guides with this newest product. Start there. Read the owner's manual, I guess, which I've never done in my life, but this is the actual right place.
Cool.
They're putting some work in there. And if you follow kind of that hierarchy of needs, you're going to get pretty close. Cool. Is that good?
Yeah, that makes perfect sense. I think read the manual is some really good advice, but I think many people are still going to keep on never seeing it once. If you were on a desert island, or you were stuck in one place in the world and you had to take one bike, where would it be?
Sorry, what bike would I choose?
And where would you go if you were stuck in one place in the world to ride bikes?
Oh, well, I'm in New Zealand right now, and this is a beautiful place to be stuck. So it's here.
That'll do it.
This is a good island.
And what bike would it be on?
I have right now. I'm riding the Pivot Firebird, and I am absolutely loving it. So, that's the one I would pick. I don't know a better one at this point. So
there we go. Okay, thank you so much, Tim. Really appreciate it.
Yeah.
Thank you guys for listening. If you want to check out more, then be sure to subscribe to Spotify, Apple Music, YouTube, whatever you're listening or watching to this on. And thank you for checking it out. I think it's time that we go get some lunch.
Yeah.
Thank you.